Hi, Ami. How are you doing?
Hi, sir. Yes, I'm good, thank you. How are you?
Very good, very good. So, how is winter so far?
Oh, in England. Yeah, it's really like icy cold, like it's
Mhm.
bitter cold, but it's just wind for now and ice on the roads and stuff, but not snow yet.
I
But
see.
apparently there will be snow in a couple of weeks, so I'll let you know.
What's the temperature around?
It's around like 3 to 4.
-3
Yeah. No,
plus?
3. It's no, sir, but it is cold. I'm not joking. 3 for us is like piercing into our soul.
How could you get ice in 3?
There's ice on the what is it called? Wind cars and things
I
and
see,
on the
I see.
sides,
Oh,
yeah.
okay, right in
But
the
not on the
morning.
road. Not on the
Okay,
road.
okay. On the car, you got
Car,
something.
car, yeah, yeah.
Oh, I see. Okay, okay.
It's
That's
still cold.
fine.
Yeah.
Okay, okay. We get
Obviously
that.
not like Canada. You're gonna tell me that you have like a lot of snow already.
No, no, that much of ice or snow, whatever you may call, normally
Mm.
when we go for a walk in the morning, comes on our eyebrows. while, while,
So that's a
while we
normal.
exhale, when we exhale, right? See, it's very interesting.
Yeah,
When you exhale, the air is quite warm. And as
yeah,
soon as it hits your eyebrows or mustache, if you have, it
yeah.
forms snowflakes. They're right there.
Oh,
That cold, you know.
yeah. That's what I've seen. I've seen men with their. All right. Well, I've seen that in the movies, but
Very
still.
interesting. Anyway,
That's cool.
we have minus and we have light snow today, which is
Right.
considered to be a not that bad, but a good weather.
Yeah,
It's okay
I
kind of
guess.
weather for December for us.
Yeah, we're
Anyway,
definitely completely different. We got the heaters on, boilers, and lots of layers
correct.
in the
That's true.
house.
That's true.
Mm.
That's okay. So that's fine. Let's begin with our mathematics. Like, what are you doing at school and what do you want to do today?
So I've actually got this big test apparently coming up because usually we have mocks in February,
Mhm.
but the school thinks that we're not going to do exams or something, so they have these things called tags, which are like teacher assessed grades, and
Right.
they want to like base it off of like year 13 stuff that we've done so far. So you know the couple questions that we were going through last week. And I just wanted to finish off this week. So it would encompass stuff like that from various topics that we've done, which would be
Okay.
really helpful, and a bit of the moments and mechanics stuff that we've covered, like you know the moments and then the friction stuff as well. So I was
Correct.
hoping if we could go through some of those
Sure.
questions.
So let's take both the varieties, whatever you have.
Okay.
Yeah. So you can share this. You can, let me just give you, yeah, you can share the screen.
Mhm. This one, I think the last thing that we did was, let me check.
This one we didn't do. I
We
remember.
didn't.
We didn't do
Oh
this.
yeah, this was the last
Yeah,
question,
yeah,
right?
yeah. We
Yeah.
did this wave equation, which we call the trigonometric equation.
Wave equation. That's
Yeah,
it.
correct, correct. So can you read the question?
I can.
Hmm.
So an arithmetic series has first term a and common difference 2a plus 1.
Mhm.
Part A, prove that the sum of the first n terms of this series, Sn, can be given by Sn equals n over 2, and then basically the formula.
Yeah, yeah, that's fine. So general formula is n over 2. Can you tell me? 2a.
N over 2, 2a plus n minus 1, n plus 1
And
d.
d is, yeah, and d. Correct. So
Yeah.
that's the formula, right? So in this case, d is given to you as 2a plus 1. So just substitute. Oh, okay. Just substitute and get your answer.
Yeah, why is that 4 marks?
Oh my God.
Surely not.
So 2a, yeah, there's nothing more than that. Plus
What?
n minus
So 4
1
marks for just
times
substituting.
2a plus 1. Correct. So if you remember the formula, you got 4 marks. Great. So let's move on to the second part, which is only 3 marks. Okay, not bad.
Why am I refusing to believe that that is all you had to do? Okay, well, if that's what my exam board wants to do, then
Good.
sure.
Yes.
Part B. Given that A is 4, find the value of n such that Sn equals 11225. So
Okay, why
again,
not?
something.
Yeah, just substitute. 11225. A is
Yeah.
4. So write n over 2. A is 4 means 2 times. Let me write 4 now. And then we have all this, right? Which is plus n minus 1 times A is 4, 8 plus 1 Correct. So you get 1, 1, 2, 2, 5 equals to n over 2. You can multiply that. We'll see how to solve it, right?
Oh yeah.
Plus 4 is 8. And here we have plus 7 times n minus 1, right? So this is a quadratic equation in n. You can solve, right? So
Mhm.
multiply, open the bracket. So you get 2, 2, 4, 5, 0, right? I multiplied everything by 2.
Yeah.
Multiply everything.
Sorry.
Yeah.
Sorry, my mom just came in.
Okay, no problem. So you get this, which is equal to, I'm so much focused on the screen. I didn't see anything on that side. Okay.
Oh, right, okay.
So it is n times within the bracket 8 plus 7n minus 7, correct?
Yeah. So do you want me to zoom out if that helps?
Oh, yeah. That should help.
But it's only because the writing goes quite
Yeah,
small.
that's okay. We don't need that part now.
Okay.
So we have 8 minus 1 is, so it is, okay. So let's open the bracket. So 8 minus 1 is n, okay, plus 7n squared is 2, 2, 4, 5, 0. So it's a quadratic equation. Can you now factor
Sir,
this? Yes.
sorry, 2 seconds. So when you did 8 plus 1, which is
So you get
9.
9. Oh, 9, not 7. Oh, that looked like 1 to me. Sorry. So it is 9. Yeah, you're right. So 9 times. Good.
4 times 2, 8. Yeah.
9.
Okay.
So 9, this is 9, right? So minus n. So this is minus n. Okay. So you get 9n minus n, okay, minus 9n squared. 2, 2, 4, 5, 0 equals to 0. Correct? Is that correct?
Mm-hmm.
Now, see, you have to factor this. How will you factor? Tell me. What is the best way of factoring this equation?
So can you times the 9 to 22450?
Yeah. So 9 times 22450. So how will you find the two numbers which have sum of minus 1? This is negative. Yeah?
I will just sub in some values in the calculator and hope for the best.
I'll tell you the best way. Because the difference is only 1, the number is very close to square root of this number, correct? So use your calculator, find square root of this number and take plus and minus 1 value. Just check.
So 9 times 22450, square root of that. So 449.
449. Point something, right? So that means 449 and 450 should work. Check.
So 449 times 450.
Yeah.
Oh, yeah.
So 450, right? Minus,
it works.
It works. See, this is very good strategy. Try to understand this part. Very good strategy for factoring, especially when you realize that the middle term has a coefficient of 1, correct?
Oh, yeah.
Now it is easy, right? So now you factor. You can take 9n common here. And you get what? N minus 9 times 50, right? Plus here, what is common? You have to get n. So the whole thing has to be common. Do you understand? 449 has to be common. And you should get n minus 50, right?
Oh, so minus 449 over 9.
So n minus
and 50 is also a value.
Times 9n plus 449 equals to 0. You get the idea?
Yeah.
So, and it's an arithmetic series, has the first term as a, and the common difference is this. If a, they are given as 4, and we want more numbers, right? So we are looking for a positive number, correct?
So 50.
So n equals 50. Is that clear to you? So
yeah.
So what you learned here is, if you are given an equation which happens to be something like this, don't get scared, okay? Just do
because the values are so big.
Just do square root and you get both your terms.
So square root of 9 times
product, yeah. Whatever the product is there.
Okay.
Especially when the sum is plus minus 1, because it's very close to 1, right?
Right,
so
right.
Two numbers are very equal. They have difference of only 1, right?
Yeah.
That's the whole idea. So get n equals to 50 as your answer for this question.
Wait, so how come we took the positive value?
Okay, because n was 4, right? So they gave you a was 4, right? So a equals to 4. And difference is 2a plus 1. So a is positive, so the terms are positive, right?
Oh, so you have to take positive value. Okay.
Yeah.
No, it's just because do you write both values down?
Even otherwise, when you're talking about, when you're talking about the series, n terms, number of terms is always positive, correct?
Oh, yeah.
Number
You can't
of
have
terms
like
cannot be
negative number. You're right,
Yeah.
right.
Number of terms cannot be negative. So you can see it that way. That is better actually. N has to be greater than 0. So
Right.
remember, n has to be greater than 0, right? It's a discrete number greater than 0, right? And it belongs to whole numbers. Is it okay?
Yeah, that's clear.
Yeah. So let me clear this and we can look into the other part. Well, that was a good question. I mean, yeah, good question means giving you more marks, right?
Yeah.
Good question.
All right. So yeah, this is a sigma notation one. So evaluate the, is it sigma? Is that how you say it? I don't really know how to say it.
Sigma. You don't
Oh,
know
okay.
how to say it. Good job. Half of sine x. Let me write it big and bold so that's clear, right?
Yeah.
And the sigma notation is you have to sum from n equals to 1 to infinity. And it is half of sine x to the power of n. You get the idea. Sigma means sum of terms, right? So if you want to write it as a normal series, this is a series, right?
Yeah.
So if n is 1, in that case, you get what? You get half of sine x, correct? Plus, if n is 2, you get square of these numbers, right? You get half of
Sine squared x.
sine x. Half is also squared. Both are squared. And then you have half of sine
Oh,
x
yeah.
cubed. Do you see that?
Cubed. Yeah.
And this is going till infinity. That's the series given to you. And you want to find the sum of this series. Let me write S here since you're scared of sigma, right? So the sum of this series.
Thank you.
And let me write infinity right there, right? So sum of
Yes.
infinite terms of this series. Now, do you recognize the series? What kind of series is this?
A
Geometric.
geometric series, but the addition, I need to know the addition sum formula.
Correct. So geometric series, right? So what is A? A is equals to half sine x, correct? The first term.
Yeah.
And what is R? What are you multiplying each time by?
By
Same term.
n.
Same term, right? Half sine x. Therefore, it became square, correct?
Oh, yeah.
It became square because A times A is A square, right? That's what you
Right.
right? So you're multiplying by A itself. And so you need to find some of the terms in geometric series. Do you remember the formula?
A times R. Oh, you do. Yeah, there's two versions, but yeah, 1 minus R to the power of n.
Yeah. So
Over 1 minus R.
if R is less than 1, it's better to write 1 minus R, right? But is R less than 1? Can you tell me?
Is R less than 1?
Because
oh, yeah,
half is less than 1.
Oh, wait, can I check?
Yeah,
half sine x.
R has to be less than 1 because sine x is less than 1, right?
Yeah.
You're multiplying by half. So it is even less than equal to half, correct?
Right.
It is less than equal to half, correct? Maximum.
Yeah. So just a quick question.
Yeah.
Isn't there an infinite, like, sum to infinity formula, which is like 1 over...
Yeah. We'll derive. See, let's see. So if I do sum to infinity, means n is infinitely large, right?
Yeah.
And R is less than 1, right? So this will reduce to what? A over 1 minus R. Since R to the power of n approaches, I'll write like this, approaches 0, right?
Oh, you derived that formula from that one. Okay.
Yeah.
That's helpful. Yeah.
Oh, yeah. So you see that. So you don't have to really remember this particular formula. You actually can always get to this. A over 1 minus R. Is it clear?
Okay. Yeah.
So now you have your answer here. So this sum series is basically A is what? A is half of sine x, correct? And 1 minus R means 1 minus half of sine x.
Yeah.
Right? So you can simplify this. half and half cancel, like you can just multiply by 2 both sides. You get sine x. And this is 2 minus sine x. Is that okay?
Yeah. So is that the answer?
Yeah, this is
You
the
can't
answer.
simplify further.
No, we can't do much after this, right? Because the limit of, you could actually, I mean, that's it.
Take sine x out or no? No, that won't do anything.
That won't do anything. So if you divide by sine x, you get 2 over sine, it doesn't matter.
Yeah, yeah.
But you have an idea that sine x is less than 1. So maximum value, if you have to find a range.
Yeah.
So the maximum value of this will be when sine is 1, correct? I mean, you can just plug it in, 1. If you plug it in 1 here, so you get 1 over 2, right? So if sine x equals to 1, in that case, I mean, I'm not saying that our question has been solved at this stage, correct? And we're just trying to work out, if we are given that expression, what could be the maximum and minimum value of that expression? So let me change this to question number 2.
Oh, that's like a kind of like a reciprocal function.
Yeah. So the question could be, find the range.
You're trying to graph it.
Of the function, which is this. Range of this function.
Oh, okay.
So in that case, what? Sine x maximum value could be +1 and minimum could be -1, correct?
Yeah.
Plug in those values and see what you get.
But so when you know the denominator, we can't make that equal 0. So 2 minus sine x. It can never because it's only 1 and -1. You won't get it as 2. Yeah.
So if you plug in 1 for sine x, then you get 1 over 2 minus 1, which is 1, right? 2 minus 1 is 1, correct?
Well, are we in degrees?
Sine x. I'm writing sine x as 1. Sine x could be maximum 1, right?
Oh, yeah.
And it could be -3 minimum or -1. So it will be -1 over 2 minus of -1. That means +1. So it is -1 over 3, right?
Yeah.
So sometimes if you have similar expression, what could be the range of this? Then the range is between -1 over 3 to 1. Do you see that range?
Yeah. Oh, okay.
You normally have questions where part A is something, B something else, C is something else, correct?
Sometimes, sometimes they're linked, but sometimes they're independent of one another. So like this question, it'll be a really like good way to sneak that in.
Correct. But otherwise, this was a straightforward question. I think there are some parts missing to it, which could be added something like this. That's the whole
Yeah.
Right? Yeah, they can actually get into the derivative of this function and find something else, maybe.
Yeah.
Anyway, for now, this is good, right?
That's good. Yeah.
Perfect. You can share any other question if you have. Okay, so that's the solution, right? So we got n equals to 50. Same answer, correct. And this also we got the same thing, sine x over 2 minus sine x. Perfect. Yeah.
Wait, so why for part A did they do all of this if we can just sub it in?
No, they also substituted. They just showed you 4 more steps. They substituted.
Why did they show so many steps though? Because the formula is given to us.
Oh, I see. Because it was 4 marks.
Yeah, I know it's 4 marks, but like we know the formula. Do we have to prove the formula or something?
No. You don't have to do all this. No. You don't.
Oh, so I don't need to. I can just say, here's the formula, sub these in.
Formula is this, sub it in and get the answer. Yeah.
All right.
So we do. Correct. Good observation.
Oh, okay. Where are these questions? Sorry. No. Oh, that's what we were doing, right?
This is a solution or a question.
Oh yeah, these are solutions to the question. Sorry, I don't know what's
a question for this.
They've given us the solution, but not the answers.
Okay, so probably your teacher has given you some selected questions.
Oh, right.
Yeah, remove those. Okay. Anyway,
question 8.
Can you please read it?
Yeah, so a positive sequence of numbers A1, A2, and A3 is defined such that an plus 1 equals half times an plus 6 over an plus 5, where a1, like the first term, is 5 and n is greater than or equal to 1. So part A, find the exact value of A2 and A3.
Oh, okay. So you can always.
So Yeah, so for A2, n equals 1, and for A3, n equals 2.
Yeah, yeah. Substitute, right? So we have 5 here plus 6 over 5 plus 5, correct? So which is what? Half of 5 common denominator, 25, 25, 50, 56. Correct?
Yeah.
25, 25, 56, 56. And so this A2 is basically 23 over 28 over 5, right? Check the calc.
5 times 28 over 5. Yep.
Now plug it in this value. So you get half of 28 over 5 plus 6 over
Plus 6 over 28 over 5.
over 5 plus 5, which is half of.
6 over that.
Now 5 times 28 is in the denominator. Multiply 28 square, whatever. Use calculator. Tell me what the answer is.
Don't do it the hard way.
Yeah.
Oh, I'm getting a decimal. That doesn't look correct.
No, that's different.
Let me just quickly.
This is 6 times 5, okay? Not 6.5.
Oh,
Yeah, yeah. I did 28 over 5, correct?
but why are you timesing? Oh, because you're doing it.
Here is in denominator, that's why.
Right. So 28 over 5, add 6 times 5, which is 30 over 28, plus 5
Correct.
times 0.5.
Correct.
817 over 140. So it is a decimal, they just want the exact value.
Yeah. So, okay, whatever. So you got this part. Find exact values. Just write down these two. Okay. I say find exact value of sum of first 4, 1 to 3. N equals to 1 to 3 of an minus 1, right? Of an minus 1. So, okay. So you have
You just sub it in.
Yeah, just sub it in. Yeah.
Oh.
So n is 1. Okay. So that means an is 1. So a1 minus 1, correct?
And A1
Plus
was 5. So 5 minus 1.
Plus a3 minus 1. Is that clear to you?
Oh, so if you got the other ones wrong, you get this wrong.
Yes, sir. That's for sure. That is for sure. Yeah. So use calculator, get your answers correct.
Yeah.
Okay.
That'll be error carried forward. So the first bracket equals 4.
Yeah, the last one is complicated. Yeah. Well, anyway, use calculator and figure it out, right?
Yeah. Is it not doable, sir, in your head?
Use calculator, figure it out.
The last one's a bit of a killer. 677 over 140.
Yeah, whatever you get, right? You write down your answer. 677.
Oh,
Yeah.
no, sorry. I was doing the last bracket. Let's add them.
Or do them all. Yeah. Whatever you get. Yeah.
Yeah, so 1881 over 140.
Okay, whatever. Anyway, it's your calculation, correct?
Yeah.
But you understand the term. It is an minus 1 and everything goes. Therefore, important thing here is you have to do this. Do you understand? A1 minus 1, A2 minus 1, A3 minus 1. Add them all.
Right.
Not
and
just
write it like you did. Yeah.
Yeah, not write A1, A2, A3 minus 1. Then it'll be wrong.
Right. Oh, do you think that's what most people do?
Yeah, so some people will be just doing A1 plus A2 plus A3 minus 1. Correct. So that
Right.
It is minus 1, minus 1, minus 1, minus 3.
Yeah. Oh, right. So they will add them all up and then minus 1. Yeah, that will get a different solution.
Yeah, okay. So that's a key thing, I think. That's the reason for putting it here. I think so.
Oh, I see. Yeah.
So let me clear the screen and see the next question. What is it? C.
So show that an plus 1 minus an equals minus an minus 6 times an plus 1 over 2an.
Okay, so this is also, we can derive from here, right? So we have an plus.
That can be an.
Half of an plus 6 over an plus 5. Okay. So we have to get what is an plus 1 minus an, right? So we have derived from here.
We just take that formula minus an, right?
Which formula?
The one that you just wrote down.
Yeah, minus an. Yeah. So what is an? How do you do? You open this bracket and then figure this out, right? Because there are two an here, right?
Do we need to find out what an is? We can just put it in because they're like terms.
Yeah. So let's open the bracket because they have two an in the denominator also. So if you look at this term, you see that?
Yeah.
We have an plus 1. Let's keep this because this 2an is common denominator. 2 times an. Because you have 2 times an here in the denominator. Do you see that?
Yeah.
So let me just open the bracket, make common denominator. So we have an square here, right? Plus 6.
Oh, you're opening the bracket of the one they've already given us. No,
Yeah,
you're opening the
plus-
bracket of that one.
Yeah, plus 5an. See,
But we need
because,
to show that though.
no, we have to derive this, right?
No, we have. I thought we were showing that the formula they've given.
Yeah. So first we got something given, right? We have to start from what is given to us, correct?
Yeah.
Now we have to find what we have to show that this is the formula for an plus 1 minus an, right?
Oh,
So-
sorry. You know the
Yeah.
two brackets above 2an. I thought you were expanding that. You weren't. You were expanding that bracket that you wrote in red, right?
Yeah, I just on the right hand side, I took 2 times an in the denominator. So because 2 is getting multiplied with anything. Do you want me to redo this part?
Yes,
Let me-
please.
Yeah, let me redo this.
I'm just confused. Well, what part you're expanding? That's all.
Wait, I'll do this. Don't do this.
Thank you.
So let's do it in one by one. So first, let me write half here itself and take this an common. Is it okay? We did it
Yeah.
earlier also. So we have an square plus 6 plus 5an. Is it clear to you now?
Yeah.
And now I'm multiplying this by 2 only. So we have an squared plus 6 plus 5an, right, over 2an. Is it okay now?
Multiplied it by 2.
Just half. Yeah, multiply it by
Cool.
half. Now they basically want an plus 1 minus an, right? So what I will do is I'll do minus an both sides.
Oh.
Do you see that? We still have the
Yeah.
same denominator. So this is, I think, the simplest way of doing it. So we will now take this
Oh.
2an common, right? And we have
Gotcha.
an square plus 6 plus 5an minus 2 times an squared. Do you see that? Common denominator. So we get this.
Wait, where did the 2a squared n come from?
Multiply this. You took a common denominator, right?
Oh, right.
Right?
Yeah.
So now minus 2an and an is minus, right? So we can take minus common. We have a minus common here also. That's very good. So we are closing to this result. So we'll take negative. We will factor out negative outside, right? So let's do it in 2 steps. An square minus 2an square is minus an square, correct? And then we have plus 5an
yeah.
plus 6 divided by 2an. Is it clear to you? Now I will take
Factors.
minus common. And what do I have here? An square minus 5an, right?
Minus 6.
Over 2an, correct?
Yeah.
That's a quadratic equation factor. Product of minus 6, sum of minus 5. 3 times
So
2.
minus 6 and 1.
6 and 1. Yeah. So that gives you the answer, which is minus of, you can write down the answer now. Denominator is 2an as expected. And we have here
an minus
times
6.
an plus
An plus 1.
You got this.
Yes, I think the part that I wouldn't have got was, where you subtracted an on both sides.
That is a key. You are right. Oh, yeah, because otherwise I was also thinking, how do I get this? I mean,
Yeah.
plus and minus, because this was quadratic equation. Very difficult to solve otherwise.
But if they didn't give it shown like an plus 1 minus an, how would you know to do that?
Because
It's really hard.
yeah, because you see an 2an in the denominator on the right hand side.
Yeah.
That means let us maintain this 2 times an. Let's not disturb it because we want that in the denominator. You get the idea?
Right,
So,
right.
the beauty is that your questions actually help you to find the solution. So observe your questions properly, and then they will guide you to get the right answer. That's what I do.
Okay. I see.
Yeah. So
you're saying it's kind of easy. I feel like in the moment though, because I know they've given it, but then when you can't get the answer because it's already given, that's when it becomes really hard. And then I keep going round about like the bush about it because it's already given. So surely I should be able to do it easily. But sometimes that's not the case. So
it's not so easy. Let me be very frank. It's not so easy. It's from my experience. I've seen so many questions like this, right? So, and I know like they want us to kind of get this answer. So I'm only looking at how to get this answer. You know what?
Yeah. So I'm like kind of forgetting everything that I know about the arithmetic sequences because I'm just trying to get the answer. And then that ends up me not getting anywhere. So I need to learn how to that's why this is really helpful practicing.
Good. So that's a good strategy. Actually, I like it. So what we see here is we got this function. So can we erase all this now? Did you understand?
Yes, we can.
Right?
I did.
Okay, great. Now let's see what is part 2.
So given that an is less than 6, determine whether an is an increasing sequence, a decreasing sequence, or neither. Justify your answer.
Okay. So an is less than 6, right? So an means number of terms, right? So
that means that bracket will be negative.
5, right? Okay. An is less than 6. That means an is less than 6. So this will be positive then, right? If an is less than 6, less is 5. 5 minus 6 is negative and outside also negative, right? So that means this is positive. Is that clear to you?
Yeah. Also, it's an increasing sequence.
Yeah. So now given that an is less than 6, determine whether an is an increasing sequence, a decreasing sequence, or whatever. Since the next term is higher than the previous term, it is an increasing sequence. You get the idea, right?
So is it simply substituting an into that equation?
Yeah, since an plus 1 minus an is greater than 0, right? So the next term is higher than the previous term. So it is increasing sequence. So that's what it is. I hope that's it. Okay. The only thing critical is you must have calculated the right values. You can always check your answer and figure it out.
Now I'm scared.
Let's see. Let's see. What are the values? What they did the same thing, correct?
Great. So they only showed us part C.
How did they get this expression? Did they do what I did? No. So they opened up the bracket, or they also subtracted minus an. You see right in the beginning?
Oh, right in the beginning.
Right in the beginning, they subtracted. I did it later on. I discovered we could do like this, correct?
Yeah.
Yeah, they know the answer. The thing is, they know the answer, right?
Well, the examiner is the one who wrote the question, so obviously his answer is going to look so clean.
Correct. So we did it at a later stage.
Yeah, but that we still did it though, so it's okay.
Correct. So next one. Yeah, the same thing. Correct. That's good. But what about the values?
Yeah, that's what I was saying. They didn't give it. Let me look up because that was the last question though. But let me just double check here.
Yeah, no values given. Anyway, we'll assume them to be correct. Anyway, that's the calculator work.
So don't worry, I know how to use my calculator.
So anyway, you're good because at least you're not wrong.
That's true. I can check for you later.
Yeah, no,
I don't know why it's not given.
No, I don't want to check that. That's fine.
Oh, okay. You don't care that much. It's okay. It's fine. There were simple calculator-based questions. I'm sure that'll be okay.
Yeah, so I hope we had good questions based on sequences and series, both arithmetic and geometric series, and some intricacies involved around the algebraic part to get the result.
Right.
So with that, let's end this session. And if there's any other difficulty, we can discuss it, correct?
All right. Will do, sir. Thank you so much for your help. I really appreciate it.
Okay.
Thanks.